Hey everyone, today I'm super excited to share with you my new Udemy course, Nest.js Microservices, Building and Deploying a Scalable Backend. So this course was built out of this channel and you guys asking me to build a project from start to finish, and importantly, going beyond the existing Nest.js Microservices documentation and really digging deeper to show what it takes to start off with nothing and actually build and deploy a production grade application. And that's exactly what we're going to be doing in this course. We're going to be going beyond the documentation, and I'm going to show you how to build and deploy real Nest.js microservices following best practices. I'll have all of the completed code available to you. And the goal of the course is to get you comfortable enough with building and deploying your own microservices so you can build and deploy anything you want. So we're going to be building out 4 different microservices, a common library where we share common code like database access, validation, and logging. We're going to connect our Nest.js microservices together inside of a Kubernetes cluster, actually deploy it to Google Cloud Engine, where we will have a scalable Kubernetes cluster backed by a MongoDB Atlas database. We're going to be able to integrate payment functionality with Stripe, send emails with NodeMailer and Gmail, and of course, we're going to have our normal CRUD API operations. This will all be protected with our standard JWT authentication mechanism using Passport.js and HTTP-only cookies. All of this will be automated with a CI/CD pipeline within Cloud Build. We're even going to provision a load balancer to expose our application externally. And we develop a production Dockerfile and package.json for each individual microservice, something I know you guys have wanted for a long time now. So you can find a link in the description to the full course with a coupon code applied to make sure you get the lowest price possible. Now go ahead and enjoy a preview of the course where we start building out our microservices. I'll see you there. Okay, so we're ready to get started creating our app. We're going to be making heavy use of the Nest CLI in this course. It's going to help us quickly and efficiently scaffold our microservices and allow us to add to our application as we develop it over time very easily. And it's super simple to install if you don't already have it. Just make sure you run npm install -g for global, the Nestjs CLI. So if you get a permissions error when installing the CLI, just make sure you run this command in sudo mode and enter your password. So after we have the CLI installed, we are going to use it to generate a new project, and we're going to call this Sleeper, this Airbnb clone. We're going to call it Sleeper with an R. Feel free to call it whatever you'd like, and we'll go ahead and scaffold the application. For this app, I'm going to make use of pnpm as my package manager because it is the quickest, as it caches your node modules and makes it a lot easier to run installation. So after our project is fully initialized, we're going to cd into the Sleeper directory, and we can simply run pnpm run start to make sure that our application backend server will start up. And we can see that our Nest application has successfully started. Okay, so I've gone ahead and opened up the project in VS Code, which is the code editor I will be using. And of course, by default, we have the bare bones of a Nest.js application out of the box with our main.ts file creating the Nest application through the app module, and then listening on HTTP port 3000 for incoming requests. And out of the box, we have a single app.controller, which is a get route that simply will call the app service and return a hello world string. Okay, so I've also gone ahead and now opened up Postman, which we will use in this course to test out HTTP requests against our Nest.js application. You can use whichever HTTP client you'd like. We're going to run an HTTP localhost 3000 get request at our server, and we should get that hello world response back because of that app.controller. So we can see that our app is fully up and running and ready to go. So back in our terminal, I've exited out of the Nest server, and we are ready to get started on our application. The first part of our application is going to be building out a common library that all of our different microservices can use for common operations like database access, authentication, logging, and more. The benefit of this approach is that we only need to write this common code one time, and then we can import these modules that we're going to create into each different microservice and reuse that so that we don't have to rewrite it over and over again for all of these common cross-cutting concerns. Now, the Nest CLI makes this really easy for us, so we're going to convert our existing standalone project into a Monorepo, where we'll have this common shared module alongside with each one of our microservice apps that we're going to create. It's very simple to get started. We are just going to run nest generate library, and then we can give the name of the library. So in this case, I'm going to call the library common, because that's where all of our common code between these different applications is going to live. We can stick with the default app prefix, and we can see that Nest has added this new libs directory with our common lib and then updated some different files here, the nestcli.json, our package.json, and the tsconfig. So let's go back into VS Code and take a look. We can see this new libs directory here that has a tsconfig.lib.json that is extending our root tsconfig. So our root Nest.js tsconfig is going to be shared amongst this common module library, as well as all of our different applications. And we can see the paths here that our application can use to access our common library. Next, if we go into the nestcli.json, we can see we have a project section now where we actually have our common library here specified with some metadata about it. And lastly, if we go into the new common library, we can see we have a common module out of the box with a common service and a root index.ts that is exporting these so that external applications can import them and use them. So in this lecture, we have bootstrapped our application and converted it into a monorepo so that we can easily share code. We are now ready to start building out our common library so that we can reuse code amongst our microservices and make developing our backend very easy. Let's jump right in and I'll see you in the next one. Okay, so we're ready to get started building out our common module. And the first part of our common module is going to be our persistence layer. So working with a database and working with an ORM so that we can interact with the database and save entities in our microservices. So we're going to use MongoDB for our database layer, and we're going to build it in a very abstract way so that we could potentially swap the database out with a SQL database using something like type ORM. So we're going to build this in a very generic way, a very abstract way, follow best practices. So let's jump right in. On the command line, we're going to need to add a few dependencies. So I'm going to run npm install Nestjs Mongoose, and then Mongoose itself here. So go ahead and install these dependencies. So in addition to adding our database module here, we're also going to add our configuration module, which is going to allow us to read in environment variables using a .env file using the .env package is what Nest.js uses under the hood. But this is going to make it so that we read in environment variables and we can change these variables depending on where we're running. If we're running locally or in production, we can change that out for different values like our MongoDB URI and other configuration variables we will need later on as we build out our microservices. So to add that, we'll run npm install nestjs/config. Okay, so now we have all the dependencies we actually need. We can use the Nest CLI again to actually generate our common module. So we'll use nest generate module and then do -p where we specify the project we want to pass in. Of course, if we go to our nestcli.json, we can see the list of projects we can add things to. In our case, of course, we're going to add to our common library right now. So let's add the common project here. And of course, make sure we also add the name of the module. In this case, we will call the first module database. So now we can see that the database module has been created and our common module has been updated. So if we go back to our code editor, we can see that empty database module, and then our common module is updated. So I don't actually want a common module or any of these other common files out of the box, because each of our independent microservices will import the common modules they need and only the ones they need, and also configure them independently. So we don't need any common module here. Instead, our microservices will import the database module individually with options. So now that we've created our database module, let's do the same thing for our config module. So this config module is going to be a wrapper around the Nest.js config module. And so now inside of the config module, we can actually set up the imports array here. So our imports array is going to call the Nest.js config module and call for root on it. And so of course we are going to have to import the config module from Nest.js config, and we're going to put it as Nest config module here so that it doesn't conflict with our config module. And the reason why we're abstracting our own config module and wrapping it around the Nest one is because if we were to change the underlying configuration module, in this case the Nest one, we only need to do it in one place. So it's always a great idea to try to abstract these third-party dependencies when we can, and that's exactly what we're doing with these modules in the common library. So now by calling nest config module.forRoot, we are telling the nest config module to load in any environment variables that we have in memory, and also to read in any .m files we have in our directory, which will be super important later on when we use the config service to read in these environment variables. However, for now, we can leave things alone and go back to our database module where we can prepare to initialize. So before we initialize the database module, make sure we go back to our terminal here and make sure we start up our development server in dev mode by running pnpm start dev, so we start listening to changes and make sure that our app starts up okay. We can already see a couple of errors coming from the terminal here on our index.ts, which makes sense because we deleted our common files. So we just need to delete these exports here. Now if we go back, we can see that our Nest app has started successfully, and we can continue building out our database module. So if you've seen my videos in the past, you know how easy it is to set up a connection to Mongoose here. All we have to do is add an import to the Mongoose module from Nest.js Mongoose that we installed earlier and call for root on it, and then we can pass in the connection URI for the database. So if we were doing this for a very small application, simple one, we could just simply pass in the connection URI localhost and pass in the name of the database, in this case Sleeper. And this would work perfectly fine. And to even test this out, we can go into our source folder here, and in our imports array for our root app module, we can add the database module that we just added. And notice here how when we added the database module, it automatically imported it into the libs folder. So we want to keep this import nice and clean. In case we change the directory structure, we want to target app/common, because if you remember from earlier, we updated our tsconfig here with a path section that says if we use app/common, look in the libs folder. So if we ever change the directory structure, we only need to do it once in our tsconfig here. And of course, now if we come back, we can say that index.ts is not exporting this module. So this is going to be important that whenever we want to use something from our common library, we need to export it from the index.ts here. So we're going to export everything from the database directory here, and then I'm going to add an index.ts to my database directory and export everything from the database module. So now if we go back to our root app.module in our app, we can see that there's no more errors here. And now if we go back to the terminal, we can see that our Nest application is starting up. However, it seems to be hanging, and that's because currently I don't have MongoDB on my system running. So I have MongoDB in my system already installed. I will have another video that goes over how to install MongoDB if you do not already have it. We can easily start up the Mongo server by calling mongo d --data path And in this case, my data path where my data will be saved is a folder I created called data/db. You can use whatever you want. And once the MongoDB server is running, let's go back to our database module here. And if your application still has not connected to MongoDB, as mine hasn't yet, you can try changing localhost here out for your actual localhost IP 127.0.0.1. And now if we go back to our terminal, you can see that the Mongoose module was successfully initialized and our application successfully started, which means we have connected to the MongoDB database. And if we even go back to the MongoDB logs, you can actually see that we accepted a connection on localhost, and this is the port we accepted the connection from on our Node.js app here. So we are connected to our database. However, we don't want to have to hard code this environment variable here, which is our connection string to MongoDB. Instead, we want to use our newly created config module to load environment variable in here and read from there instead. So what we're going to do here is create a new .m file in the root of our project right now, and we can actually copy over this connection string that we're using and create a new environment variable, which we will call MongoDB URI, and set it equal to this connection string here that we just used. Now back in the database module, instead of calling forRoot, we're going to call forRoot async, which lets us pass in an object here where we can take advantage of the use factory option, which allows us to inject any number of arguments here. So in our case, we're going to inject the config service from Nest.js config, and then we're going to return the actual options here using the config service. So in this case, we are going to provide the URI. We can then use our config service here and call .get to extract that MongoDB URI that we just defined. And lastly, make sure that we actually inject the config service here so that it's available for us in this use factory method. And so now if we go back to our terminal here, we can see that our application is throwing an error because it can't resolve the dependencies of the Mongoose module. And in this case, we can see that the problem is that the config service is not being picked up. So in order to fix this error, we need to not only inject the config service here, but also make sure we import from where it is being provided from. In this case, it will be the config module that we've created, and make sure you use the local one we created here. And then once we've imported that, we then go to the config module itself and then make sure in our providers array that we're actually declaring the Nest.js config service and re-exporting it. So now if we go back into our database module and save this, we can now see that our Nest application restarted and started up successfully and still connected to the MongoDB database, even though our connection string is now coming from the config service. So one final thing I want to do before wrapping up this lecture is provide validation for our config module here. And in particular, we want to enforce that the application will fail to start if an environment variable is not present here, because we need these environment variables for the application to function. So this is one of the benefits of having this common config module where we can do this in one place and one place only. In order to do this, I'll stop my development server and install a new package called Joy, which will allow us to do schema validation. And then we can go ahead and start our server back up. And let's go back to our config module where we can now provide an options object to the Nest config module here and add the validation schema. And now in this case, we can call joy.object because we're going to provide an object, and the first environment variable that we've defined that we need is of course the MongoDB URI. So let's pass that in here. We can see we get an error about importing Joy. We can resolve this by changing the import statement as import star as Joy from Joy. And then now, if we go back, we can see that Nest application starts successfully and we have no issues. So we can set the MongoDB URI here equal to joy.string, which means that this has to be a string, and we'll say that the value is required. So now if we go back to the terminal, we'll see we have no issues and our application's still running. If we were to then delete the MongoDB URI from our .m file and then go back to our terminal. We'll of course have to restart because by default it's not watching the .env file. We can see here that we have an error thrown, a config validation error. MongoDB URI is required. So we can see that we are now connecting to MongoDB and providing the connection string via an environment variable using our config module. We have successfully set up our database module, and we're now ready to start building out our abstract repository that the rest of our microservices will use in order to implement simple, reusable, and maintainable data access. Let's jump right in, and I'll see you in the next lecture.